I have kind of a fun data set here. This data set contains the caffeine content of drinks depending on what they are. Coke, Diet Coke, Pepsi, Diet Pepsi. And then different stores, different restaurants. Applebee's, McDonald's, Burger King, Red Lobster, range of them. Let's focus on the caffeine content. Okay, so if I were to ask you to sort of summarize the caffeine content in this database, well, what tools have we learned to use? Well, we have the frequency table, and we have the histogram. So let's take a look at that. So let's just take our caffeine content. We won't worry about the drink type or the restaurant yet. We can come back and play with that in a bit. We'll just take the column that has all the various caffeine levels, and let's go ahead and summarize that data by, first of all, creating a frequency table. We'll do our pivot table. All right, so same way we've been creating our pivot tables. We will set the row to caffeine content. We'll set the value to caffeine content, and we are going to be counting that. Okay, now we got to kind of narrow down our group. We got to bin our data together to make it a little more meaningful. So we will create a pivot rule, and all we're going to do is create an interval size of, I don't know, a couple milligrams of caffeine. Should make it a little more manageable. And there we go. We have our nice little frequency chart. And we already begin to see some patterns in it, where there's only a few that have this lower caffeine and very few that have this higher caffeine. But let's go ahead and graphically represent it as well. We'll do a histogram. So we'll get our caffeine data once more, all right? And then we are going to go ahead and insert a chart. Again, it gives us a scatter plot. That's fine. We can just change it to the histogram that we want. All right? If your bins come out weird, remember you can come over here to the histogram setting and you can set it to whatever you want. So let's match our frequency table and set our bin to 2 milligrams of caffeine. And there we go. Not bad. All right, so we have our histogram here that represents the data, and it kind of the same thing we saw, which is sort of low frequency on the low end, low frequency on the high end. And this really has kind of a, it's a unimodal function, right? We have just this unimodal function over here. It maybe has a little bit of a right skew, right? We're extending a little bit to the right. But there we go. It's not huge, but it's definitely a little bit of a right skew. Okay. So is this representative? Does this tell us everything we know about the data? Well, the histogram is nice, but we can't really do much with the histogram. Really do much with the frequency table. We really want a way of kind of summarizing this data that really gives us a number, something that says that this is what represents the data. A single number that allows us to do comparisons against other data sets or manipulate in various ways. We need some kind of summary of our data set that we can kind of reduce to a single number. This is what we call central tendencies. Central tendencies are a central part of statistical analysis. Everything is based around those central tendencies. We are looking for a number that represents the center point or the central tendency of our data. What is representative of our data? All right? It turns out that there are 3 primary central tendencies. Let's take a look at them. So the 3 most typical central tendencies, those measurements that we think do a good job of determining the central point of our data, are the mode, median, and mean. So we're going to go through each of these to figure out how to determine them and how they differ from each other. So let's start with the mode. The mode is the data point that occurs most frequently. That's it. You just find the point that occurs more than any other, and that's the mode. If there are multiple numbers that occur at the same sort of max frequency, then there are multiple modes for a data set. Essentially, the mode corresponds to the peak of the histogram. So in a unimodal histogram, there's a singular peak. In a bimodal or multimodal histogram, there are multiple modes. Let's look at this data set, which is a count of 10 people and the number of dreams that they claim to have in a week. So take a look at this data set, pause the video, tell me what the mode is. The answer is 8. That is the most frequently occurring number, and if we look at the histogram, you'll see that is the peak of the curve. Stock median. For median, we have to order the data set from smallest to largest, and then we take the exact middle point. So the median is the point at which half of the data falls above and half the data falls below when it is ordered. So in this case, 1, 2, 3, 4, and 5, what would be the halfway point? Well, sure enough, it would be right there at 3. There's 2 numbers below, 2 numbers above. However, if we just have 1, 2, 3, 4, the middle point is going to be between the 2 and the 3, which means we're going to have to average those numbers together, telling us that the median is 2.5. All right, so if we look at our dream data, what's the median? Well, remember the first step is to reorder the data from smallest to largest, and then we got to look right at the middle point. So, pause the video, determine the median. Well, the median is between the two 7s, so we'd have to average them together, but that's going to be 7. So in this case, the median is 7. All right. Probably the most frequently used central tendency is the mean. Many of you have probably been working with the mean for a very long time. It's just the average. The mean is calculated by adding up all of the scores and then dividing by n, or the total number of scores. So if you have 10 scores, you add up all 10 scores, you divide by 10. It's just the average, right? So this is the way that we're going to write the mean. So you might see a couple of symbols here that are unfamiliar. The biggest one is probably the summation symbol. So right here, the summation symbol is basically saying just what we said. If x corresponds to each data score, the summation symbol says take all of those x values and add them together. That's all summation is saying. Take whatever is in the summation sign, add it together. That's it. So x refers to each of our data points, the summation sign means add them all up, and n is the total number of observations. So again, this is just an average, but we're going to take each of our data points, add them all up, divide by the total. So back to the dreams data, right? We take each of our data points, x. X represents 7, 8, 8, 7, 3, 1, 6, 9, 3, 8, right? X represents each one of those scores. The summation sign says take each one of those scores, add them all up. We're going to get 60. We have a total number of 10 observations, so we divide that 60 by 10, and we get a mean of 6. Another potential way to think about the mean is it's the balance point. So if we take the histogram and we set it up so that each of the frequency bars has weight in our mind, the mean is the balance point. The point that there's the same amount of weight of data both above and below. One of the most important differences between these central tendencies that we're going to need to deal with is what happens with skew. In a normal distribution, a distribution that is unimodal and symmetrical around the mean, median, mode all are the same thing. They don't differ. However, as we skew, the median and mean get pulled in the direction of the skew. The mode stays the same, but the median gets pulled a little bit in the direction of the skew, whereas the mean gets dragged significantly towards the direction of the skew. This means that data that is substantially further away from the peak can have a dramatic effect on the mean, and that's something that we're going to have to deal with a little bit later in the class. Okay, so let's go back to our caffeine data and see how this plays out. So I'm just going to move my histogram over here to the side for reference. We won't use the pivot table that we created here for now. All right, so let's see how we might calculate the mean, median, and mode of our data. It's pretty simple, actually, in Google Sheets. Let's go ahead and we'll do the mode over here, the median over here, and the mean over here. So what we could do is we go to the cell here that we want to calculate in. We click up here in this little text box, and that's what we're going to type. We type in equal sign. The equal sign means that we are going to put in a formula, something for it to calculate. In this case, we want it to calculate the mode. Easy enough. Then in parentheses, we need to tell it what data to calculate the mode for. It's real easy. All we have to do is select the data. So I'm just going to start at the first value. I'm going to go down to the last value, and then we hit enter. We come up here, we'll see that in this case the mode is 32.98 milligrams. Now, if we were really doing this analysis, we'd probably want to round this data just to make it a little more meaningful, but that's how you calculate a mode. Right? I'm going to be shocked, but to do median is pretty much the same thing. Equal sign, median, and we do the parentheses, and we're going to give it the data to calculate the median for. So we select the data. Once we have all the data selected, we press enter, and there we go. We have our data. All right. The mean is a little bit more complicated. We got to do the actual equation. All right. So we set equal sign. The first step is we have to sum all of our scores, right? The summation sign says add all the scores together, sum them up. It's done using sum. All right. Sum is just going to take all of the values that we give it and add them up. All right. So let's select all of our scores. Okay. If we press enter, that'll give us the total amount of caffeine in all 240 of our samples, right? But that's what we want. We want the mean, so we take the sum and we divide it, front slash, by the 240, which is the number of samples that we have. Press enter, there's our mean. Okay? So we have our mode, median, and mean. Right? Now if we come over here and look at our histogram, right, remember we binned our histogram. So the mode isn't going to tell us a whole lot. This doesn't match the binning. And trying to unbin it, it would just make the data a little complicated to read. But we can see that it's generally capturing where the peak is. And sure enough, we have this little bit of a right skew. And what we're noticing is that the median and the mean is being pulled in the direction of the skew. The mean a little bit more than the median, which is what we saw earlier. So that's how you can calculate mode, median, and mean for your data in Google Sheets. I did want to show you one last kind of cool thing to show you some of the real power you can have when you're working with a computer. We haven't really broken out types of drink or restaurants. But this is the kind of thing where the pivot table can be really awesome. So let's actually select all of our data. All right, so we have all of our data. We're going to come back up here to the top, and we're going to create another pivot table. This one will be a little bit more complicated, but all I've done is selected all of my data. I'll put it in the existing sheet just over here. All right, and now, for example, for the rows, I'm actually going to say store. And then for the values, I'm going to put the caffeine content. And now instead of doing a count, I'm actually going to ask it to do, for example, the average. And now look, it'll show us the average caffeine based on the restaurant. Or maybe we do want the median. See the median. I can also change it so that the rows are by drink type. And we can see the average caffeine for drink type. Right? So we can do some really cool and fast manipulations to break it down by different variables using these pivot tables that I showed you. We'll play more with them throughout the course, but I did want to just show that kind of cool example, the kind of power that is present when we're working with this software.